everyone, this video will be talking about exponents, positive, 0, and 1. So there are certain rules around exponents that we're going to learn about, and we're just going to keep going down each rule as we go through these examples. So let's start with the first rule for exponents. So rule number 1, that is the power of 1 rule. So what do I mean by that? I mean, if you have something that's to the power of 1, whatever your base is what your answer is. It's as simple as that. So whatever you have to the power of 1, the answer is that base. Here's rule number 2. The power of 0. So for this rule, if you have a base to the power of 0, the answer will always be just 1. For example, if I had the letter or variable p to the power of 6 times r to the power of 5, and all of that to the power of 0, because my base here is everything in the parentheses, and all of that is to the power of 0, this would actually equal 1. So let's take a look at rule number 3. Product of bases. So for example, if I had a to the power of m as in mom times a to the power of n as in Nancy, this would equal a to the power of m plus n. So if you are multiplying two bases together that have the same base, you actually end up adding your exponents. So this is rule number 3. The product of bases yields you an answer with those exponents added together. Let's look at some more examples. If I had m to the power of 5 times 2m to the power of 4, now I multiply my bases together, so the product of the bases becomes 2, and then the exponent...
Okay, that was $2.55. This time you should already be in a classroom with the teacher, sponsor, coach. For us, I'm waiting for a ride. After this time, you need to have custody in the halls. Have a great weekend.
Okay, so the product of the bases is this invisible 1 times 2, so I have 2 times m, and for the exponents, you add them together. So 5 plus 4 is 9. So the answer for this example is 2 times m to the power of 9. Another example, let's say we had negative 3c cubed times d, all times 4cd to the power of 4. Well, the product of my bases here, I have a negative 3 and a positive 4. I'm going to show you what order I'm going to write these in and then explain why. So I'm going to go ahead and write my negative 12 first, and then I have c to the power of 4, and that's because I have 3 c's over here and this 1 c over here. So 3 plus 1 is 4 times d. I have 1d over here and 5 d's over here, so 1 plus 4 is 5. The reason why I wrote it number first and then c and then d is because the order of your answers should always be the number first and then the variables, in alphabetic order. Let's look at another example for that. Let's say I had 2 times a times c squared, all times negative 4 times a cubed, c cubed, times d. Well, let's think about our numbers first. I have a positive 2 and a negative 4, and I multiply that together, I get negative 8. And what about my a's? Since I want to go in alphabetic order, I'm going to look at a first. Well, I have 1a plus 3 a's, so that's 4. C's, I have 2 and 3 over here, so that gives me 5. There are no d's in this first term, and there's only one d in the second term, so I will just carry over that one d. So there is your answer for that one. Okay, so we're ready for rule number 4. Quotient of bases, where if you have a base with an exponent divided by a base with another exponent, you would get the difference in those exponents. What I want you guys to think about, instead of trying to memorize a rule here, just think to yourself, where do I have more of that value in the exponent? Are there more in the numerator, or are there more in the denominator? Wherever you have more, that's where you write your answer. It helps to look at some examples for this. So let's say I had x to the power of 11 divided by x to the power of 5. Well, where do I have more? I have 11 in the numerator, but only 5 in the denominator. 11 is greater than 5. That means I'm going to write the difference between these two up top. So again, think to yourself, where do I have more? The numerator or the denominator? Wherever I have more, that's where I will write the difference in the exponents. So since this is in the numerator, it just looks like x to the power of 6. But let's say now you had something like this. So I know I'm still taking the difference in the exponents, but this time I have more in the denominator, which means I'm going to write 1 over n to the power of 3. So I write the difference in the exponents in the denominator this time. Let's look at some more examples here. Let's say I told you, simplify the following examples. Negative 3m squared times 2m to the power of 4. Since I am multiplying here, I will multiply my numbers, so that's negative 6. And then for my exponents, you add them together. 2 plus 4 is 6, and that's your answer. Let's do another one. Let's say I had this. Well, what does that really mean? So I'm going to draw it out for you guys just so you can visualize what is going on here. So what you have here is p to the power of 0 times r to the power of 5 times itself 6 times. So that's like saying one, two, three, 4, 5, 6 times. So one of our rules over here told us anything to the power of 0 is equal to 1. That was rule number 2. So that means every time I see something to the power of 0, that is just like saying 1. And then I have r to the power of 5. So I can simplify all of this to be like this. Here we go. So this was just for me to keep track, make sure I had 6. Let's do another one. Let's say I had 6x squared y cubed all times xz squared. For my numbers, I just have a 6 here. There's an invisible 1, so 6 times 1 is just 6. For my x's, I have 2 over here, just 1 over here. So I have x, and 2 plus 1 is 3. For my y's, there are 3 over here, none over here, so I just have the 3. For my z's, none here, and just 2 here, so I just have the 2. Okay, let's do another example. Let's say I had 3m to the power of 5, all divided by n to the power of 7, and I want to raise all of that to be cubed. Well, this is like saying 3m to the power of 5 divided by n to the power of 7 3 times. I'm going to multiply my numbers together. 3 times 3 is 9, times 3 is 27. For the m's, I'm going to add the exponents together. 5 plus 5 plus 5 is 15. And for the exponents off the n, I have 7 plus 7 plus 7, which is 21.
Braulio Rodriguez, please come to the front. Braulio Rodriguez, please come to the front. Thank you.
Let's say I had 3 to the power of 5 divided by 3 cubed. Well, where do I have more? I have more in the numerator, which means when I take the difference of these, I will write the difference in the numerator, and this can simplify. 3 squared is 9. Okay, I have one more example for you guys. Let's say I had 8 to the power of 4 divided by c to the power of 5, all cubed, times c squared divided by a squared, and all of that is squared. Well, I'm going to write this out so I can visualize what's going on here. So I have all of this times itself 3 times. So to write it out, I have a to the power of 4 divided by c to the power of 5, 3 times. There's 1, 2, 3. And then all of that is times this twice. I'm going to add all of my a's together and then add the c's together. So I have 4 plus 4 plus 4 for the a component, which is 12. And for c, I have 2 plus 2, which is 4. And then in the denominator, for the C component, I have 5, 10, 15. And remember to write it in alphabetical order. So for the A's, I have 2, 4. Now I can simplify this further. Let's look at just the A's first. I have more up top, so I write the difference in the exponents on the top. 12 minus 4 is 8. For the C's, I have more on the bottom when I compare the C's. So I write the difference between 15 and 4 on the bottom. And this is it fully simplified. Good job, guys.
Attention.